Okay. So today is 3.5 day 2, still on parallel and perpendicular lines, but this time we are going to use everything we know about slopes and parallel and perpendicular right now to be able to write equations of lines. So we're going to try the poll feature real quick. All right, I've posted a poll. Go ahead and try answering the poll. I'm not sure how it shows up on your end, but it's within the Google Meet. How do we feel about our ability to write the equation of a line? This is from algebra, and no one else is going to see what you voted, so it's okay. So we've got 1 is like, I don't even remember what a line equation is. Barely remember what y equals mx plus b stood for. 5 is, I'm amazing at line equations. I remember slope-intercept form and all that good stuff. The 3 is somewhere in the middle. It should be kind of near the chat, I believe. If you see that, those little, the 3 shapes up at the top, that should be where the poll lives. Cool. All right, you have 30 seconds and I will close the poll. It is, if you're in the chat area, you see the 3 shapes that are next to the chat thing. Click on the 3 shapes and then click on the poll, I believe, is where it lives. Alrighty. Ending the poll in 5, 4, 3, 2, and 1. All right. Well, that was kind of cool. Okay. So it looks like most of us remember at least something about line equations and whatnot. There's a couple of us that feel really confident about it, which is awesome. If you don't feel so confident about it, it's okay. We're going to go over it today, and we're also going to add in all the parallel and perpendicular stuff that we've been talking about. So grab your notes, and let's get started. That's for pre-calc. This. Alrighty. So it's 3.5, day 2. Equations of parallel and perpendicular lines. Okay, so when we're talking equations of parallel and perpendicular lines, the first thing we need to do is make sure that we can find equations of lines. So we have 2 different formats that we find equations of lines in. One is called point slope. So point slope form is the format y minus y1 equals m times x minus x1. Okay, And in this one, m is the slope, and x1 and y1 are coordinates of a point on the line. Okay, so we might have seen point slope form before, we might not have. And it works very similarly to slope-intercept form that most of you have probably seen before and are used to. And this one's going to be helpful to us today because we're going to be given, in a lot of cases, a point and a slope. And if you have a point and a slope, point-slope form is really easy to use. So that's probably going to be the one that makes a lot of sense for most of us today. The other form that we have is called slope-intercept. So slope-intercept form, most of us have probably heard of y equals mx plus b, where m is still the slope and b is that y-intercept. So that was where the function or the equation or the line crosses the y-axis. Okay, and so what we're going to be doing today is we're going to be given a point and then a slope, essentially. And we're going to start off by putting things in point-slope form, but then we're going to change them into slope-intercept form. Because this version of things is easier for writing the equation. This version of things is easier for graphing it. So here we go. First example. This one, we want a line through the point 3, 5 and parallel to y equals 2x minus 12. Okay. So I'm going to show two different ways to do this. The first way is to put it into point-slope form and then change that into slope-intercept form. The second way involves about the same amount of algebra, but it's going to be using slope-intercept form exclusively. Because at the end, we want things to be in slope-intercept form. Okay, so the first thing, we need to identify a slope. We know we want it to be parallel to this line. So the slope of a line parallel to that one. Remember, parallel lines have the same slope. So what do we think the slope of our new line is going to be? Any ideas? Yeah, thanks, Owen. It is 2. So the slope of this line here is 2. And the only thing that we care about from this line is the slope. We don't care about the negative 12 or anything else. We only care about the slope. So this is going to be our new slope. And then if I'm doing things the the point slope way, then I need x1 and y1 to be this point that we're going through. So we have our slope, we have our x1, and we have our y1. And now all I have to do is plug those things in to this equation here. We have y minus y1 equals m times x minus x1. So instead of y1, I'm going to put a 5. And instead of x1, I'm going to put a 3. And instead of m, I'm going to put a 2. So we get y minus 5 equals 2 times x minus 3. Okay. So that is the equation of the line. And if you were to plug this into a grapher like Desmos or something like that, it would show you the line. But what we want to do next is simplify things a little bit and put it into slope-intercept form. So the way that we do that is that we just solve for y. So I'm going to use the distributive property here to simplify. We get 2x minus 6. And then all I have to do is add 5 to both sides to get y equals 2x minus 1 for my final answer. Okay. So that is the point slope way of doing things. You take your point, you take your slope, you plug them in, and then you simplify it by solving for y. Okay, so that's one way to do it. The other way to do it is the slope-intercept way. Okay, so the slope-intercept way takes y equals mx plus b. And we start by plugging in the slope too. We get y equals 2x plus b. But now I need to figure out what b is going to be. And the nice thing is, since I have an x value and a y value, I can plug those in for x and y and use that to solve for b. So I can go, okay, well, y was 5. So I can go 5 equals 2 times x was 3 plus b. And now I can solve for b. So 3 times 2 is 6. And then I can just subtract 6 on both sides. We get -1 equals b. So then we go back up here and plug in b. So we get y equals 2x minus 1 since b was -1. Okay, so that is the slope-intercept way of doing things. Two different ways, they got us the same answer. I tend to like this way for this method of doing things where you're given a point and you're given a slope. But either way works. So whichever way jives with your brain the best, do it that way. Okay, so we're going to pause here. Are there any questions? Any numbers we're not sure where they came from? Any steps we're not sure how they happened? Okay. If you do have any point, unmute yourself and say so, or type it in the chat. I will still monitor the chat and everything. Is that a 6 or a B? Right here? This is a B, this is a B, this is a B, this is a 6. So yeah, these are all B on the end. This is a 6. Okay, good question. Alrighty, let's do another one. Okay, this time we want a line to be through. Let's go through 4, -2. And this time we're going to be perpendicular. to, let's go with y equals negative 3x plus 2. Through 4, negative 2, perpendicular to y equals 3x plus 2, or negative 3x plus 2. Actually, hold on, sorry. We're going to go the 0.6, negative 2. 6, negative 2. Because that'll give us a slightly nicer answer here. Not that not nice answers are bad, but for example purposes, let's get a nice answer. Okay, so here we go. First thing we need to notice is that we're dealing with something perpendicular. Perpendicular. So now we have to go, okay, what's the slope of this line here? What's the slope of this one? What do we think? Nice. Yes, it is negative 3. And if I want something that's perpendicular to this, then this is really like negative 3 over 1. So we have to flip the fraction and change the sign. So my new slope is going to be positive 1/3 for my perpendicular line. So perpendicular slope is 1/3. Okay, then this is my x1, y1. And reminding myself, I'm going to do the point slope way. If you prefer the slope intercept way, go for it. We have y minus y1 equals m times x minus x1. So my new slope is going to be 1/3. x1 will be 6. y1 will be negative 2. So we have y minus negative 2 equals 1/3 times x minus 6. Okay, then we have to distribute. So we have 1/3 x, and then 1/3 times 6 is just 2. You can do it in a calculator, or you can do it just thinking with fractions, you multiply straight across. So it would be like 6 over 3. And then minus negative 2 is like plus positive 2. So over here we have y plus 2. All right, then our last step, we subtract 2 from both sides. And we get y equals 1/3 x minus 4 for our final answer. Okay. So kind of our steps here. We decide what the slope's going to be. We plug in the point and the slope. We solve for y. Make sure when you do the distributive property that you give it to both of the numbers. That's one common mistake that people make. Okay. Let's do one more, and then I'm going to have you guys try one. This time we're going to go through the point -2, 7. And perpendicular to 4y minus 3x equals 5. Okay, so this one's going to take a little bit of extra work at the beginning, because I can't pull the slope out of that graph or out of that equation right away. So first we need to change this one into slope-intercept form to find the slope. So what I would do first here is add 3x to both sides to get the y by itself. So now we have 4y equals 3x plus 5. And now we're almost there. I just have to divide by 4 on both sides so that we get y equals 3/4 x plus 5 over 4. And now it's in a format that I can take the slope out of. So for this one, we had to do a little bit of an extra step to find our slope. Okay. So now looking at this line, the original slope is 3/4. But we want a perpendicular slope. So to find a perpendicular slope, we flip the fraction and change the sign. So what's my new slope going to be? Go ahead and type in the chat if you think you know what the new slope is going to be. Remember, flip the fraction, change the sign. There we go. Nice. I agree with you. It's going to be -4/3. -4/3 for our new slope. So this one's going to generate a little bit less nice of an answer. Yeah, yikes. All right. So here we go. -4/3. So putting this thing into point slope form, y minus y1 equals m times x minus x1. Okay. So here's our x1, y1. So we've got a 7 here and a -2 here. And then we have a -4/3 for the slope. So we get y minus 7 equals -4/3 times x. And then minus -2, remember, is like plus +2. Alrighty. And this one is not going to be a real nice answer because 2 is doesn't go into 3 evenly. But anyway, and neither does 8. Here we go. Now we distribute. So we get -4/3 x, and then 4 times 2 is 8, so it's going to be -8/3. Since we just multiply the tops when we have a fraction. And then we still have y minus 7 over here. Okay. Now here's the fun part, because I get to add some fractions. So we go +7 on both sides. We get y equals -4/3 x. That stays the same. But we have to do 8/3 plus 7. Or sorry, -8/3 plus 7. And the easy way to add fractions is to make a common denominator. So instead of 7, I'm going to multiply 7 by 3 to get 21/3. Because 21 divided by 3 is 7, so that's the same thing as 7. and then we add them together. Most of your answers on homework and things like that and tests are not going to be as ugly of answers or, you know, involve lots of adding of fractions and things like that. But that's what we get today. So let's see. That would give us 21 and negative 8. It would be 13 thirds. So we go plus 13 thirds. And that would be our answer. Okay. So that one was not real pretty, but hopefully we get the idea there. Okay. So looking at that one's a little bit longer because we had to add that step at the beginning where we find the slope of this and then find the negative reciprocal slope. And then we can start the way that we were used to doing. Are there any questions at the moment? Any numbers we don't know where they came from? Any steps we're not sure why they happened or how they happened? Okay. I'm going to have you guys try one next. Okay. So this time we're going to go through to -1 and parallel to y minus 4x equals 1. Okay. So try this one. Remember on this one, you do have to move the x over to get your slope first. And this time we are doing parallel. So that tells us same slope. Go ahead and give it a try. When you think you've got it, type pumpkin spice in the chat. All right, as people start to finish, if this is how you started things out, you're on the right track. Or if you did the slope-intercept method, you would have started things out like this. All right, so either way that you chose to do it, the point slope method here, plugging in -1, 4, and 2, distributing, and then subtracting 1 from both sides, you would get y equals 4x minus 9. So if that's what you got, you are correct. If you chose to do the slope-intercept way, you would start out with y equals 4x plus b, plug in -1 for y and 2 for x, subtract 8 from both sides and get -9 for b, so y equals 4x minus 9, either way. Okay. One moment. All right, I posted a quick poll. Which way do you prefer? Do you like the point slope way or do you like the slope intercept way of doing things? I'm just curious. Which one do you prefer? This point slope way of doing it or this slope intercept way of doing it? What do we like better? All right, 10 more seconds to vote. And closing the poll in 5, 4, 3, 2, and 1. I'll show you guys the results on this one. We had 14 of you vote, so there must have been several people who are undecided. We've got 10 votes for point slope and 4 for slope intercept. So it looks like most people prefer the point slope way of doing it, but some people do prefer slope intercept. And again, I don't care which method you choose to do it, as long as you get your answer to that point at the end. Okay. So we're going to go ahead and get to the part where we start the assignment. Today's assignment is in big ideas. And I'm going to go over a couple of problems with you, just like we usually do, before we get started. But if you would like to, or if you already feel comfortable with this and would like to just go get started on your own, you are free to do so. But yeah, I will also do some over here. Okay, so let's show that, and here we go. All right, so the first one is a review a bit from yesterday. It's finding the slope of each of these lines and then deciding if they are parallel, perpendicular, or neither. Okay, so remember, finding slopes, we subtract the y values on top, we subtract the x values on the bottom. So for the first one, the top number would be 9 minus 5, which is 4. The bottom number would be -8 minus 10. -8 minus 10 is -18. But this reduces, so we want to make sure that we reduce the fraction. These are both divisible by 2. So 4 divided by 2 is 2. 18 divided by 2 is 9. And we can check ourselves along the way, make sure we've got the right fraction going. Then the second one, y minus y, we have -6 minus -4. So that's like -6 plus 4 on the top, which is -2. Then on the bottom, we have 11 minus 2, which is 9. And okay, we've got the same slope going for each of these. If the slopes are the same, they are parallel. So that's what we would pick there. Okay. It's minus -4, Christy. So since we're subtracting them, good question. -6 and then minus -4 makes it into a plus +4. Yeah, so this is a good one to make sure that you actually write down, especially if adding and subtracting integers and keeping track of all of that in your head is hard. I've had a lot of practice with it, and even I mess up sometimes. So making sure that we're writing these ones down if you got paper nearby, that's a good call when we're doing our big ideas homework. But anyway, so that one's kind of a review from what we did yesterday. This one, though, we've got write the equation of a line going through the point -8, 0, perpendicular to 3x minus 5y equals 6. Okay, so the first thing that I would do here is switch this line into slope-intercept form so I can figure out what the slope is going to be. So I'm going to switch to paper here for this one. I'm going to write down the question. We want it to go through -8, 0 and be perpendicular to 3x minus 5y equals 6. Okay. So then this one becomes just like a question that we've done before. We have to go, okay, minus 3x on both sides. So we get -5y equals -3x plus 6. Or at least that's how I like to write it, so that it looks a little bit more like slope-intercept. And then we divide by -5 on both sides to get y equals -3 divided by -5 is positive 3/5. Then it's minus 6/5. Okay. So then the number that we care about from this one is the slope. So the slope here is 3/5. We want to make a perpendicular slope. So we flip the fraction and change the sign to get -5/3. -5/3. And then this is our x1, y1. So when we do y minus y1 equals m times x minus x1, we plug in 0 for y1, -8 for x1, and -5/3 for m. So y minus 0 is just y. Then -5/3 times x minus -8, which is really like adding positive 8. Then we distribute, get -5/3 times x. And then 8 times 5 is 40, but it's a -5, so minus 40/3. So this would be our answer. Let's check it on big ideas. Make sure that when you do 5/3 as your fraction, you put the x next to it, not on the bottom of the fraction. That's a kind of typing error that we can get a lot here. And then we had minus another fraction, 40, oops, not 10, 40/3. So what I would do first here is check and make sure that this is the answer. So once we've got that, now we can graph the lines. See how this works. Graph a line. So we want to graph both of the lines to check that they are perpendicular. So first, this original line was y equals 3/5 x minus 6/5. Okay. No, we can't. Come on. And then our other line was passing through negative 8, 0. So let's go to negative 8, 0 for a moment. Negative 8, 0. Gosh, that's not where that is. Come on. This graphing tool is frustrating. Okay, negative 8, 0. And then we go down 5 and over 3. So 1, 2, 3, 4, 5. 1, 2, 3. So that's our new line because that was the slope and this was the point that it was going through. And then our other line, let's see. What if I plugged in 0 there? Then we would get 3, 2. So it'd be then the slope was 3/5. So 1, 2, 3, 5. Okay. So the way I did this one for graphing purposes, this line is not the easiest to graph from either the format that it's given in or from a slope-intercept form, just because it's got a fractional intercept where on here we can't really grab a fraction very easily. And then it's also got fractional slope. So what I did was I grabbed the x-intercept instead. So I plugged in 0 for y. And so that would be 0. So you get 3x equals 6, and then divide by 2 on, or divide by 3 on both sides to get 2. So this point, 2, 0 is also part of your graph. So that's another way that you can find a nice point to graph is by plugging in 0 for y and see what you get for x. But anyway, so that's what that graph would look like. I plotted the point 2, 0, and then I used the slope to go up 3 over 5 for that line. For this one, I plotted the point negative 8, 0, and then I used the slope negative 5 over 3, so down 5 over 3 to get my next point. So that's how graphing will work for these. Okay. So if you're having trouble with the graphs, let me know. We can always work on more of those. This assignment has 12 total questions, and we just did 2 of them. You guys have the rest of the period to work on the rest of the questions, and then I will also post an exit ticket towards the end, as usual. And then I will be here until 10:50. So feel free to pop back in and ask questions up until 10:50. And then we have AR time today for the first time. So intervention/enrichment starts at 10:55. So at 10:55, you need to be in your intervention class if you have an intervention, or doing whatever enrichment you like if you have enrichment. Okay, go ahead and get working. If you have questions, feel free.